Hey everybody, this is Larry. This is day 23 of the July Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem. So today's problem is binary tree pruning. I usually start these live, so it's a little bit slow, a little bit awkward. Fast forward, do whatever you need to do. Yeah, I've been also doing these a little bit later in the day because the internet's been a little bit sketchy, so apologies for that, but yeah. Okay, let's see. So I also usually do these live, so it's a little bit slow or whatever. Just fast forward to wherever you think is important or interesting. Yeah, hopefully we'll get back to our regularly scheduled problem in the future. But okay. So basically, you want to remove all the subtree with zeros. Okay. So this is basically going to be a depth first search type traversal of the tree, so you could do this in linear time, even though the number of nodes is only 200, but it's probably a good practice to try to do things as linear time as possible, especially when you're dealing with a tree. Yeah, and I think, oh yeah, and the other thing I was going to say is that this is, I said that for search, but it is probably going to be a post order, right? Because you're traversing the entire tree, so I think that should be good. So now you can either do it in two functions or maybe do it in one function, recursive function, depending on how you want to go about it. Don't really feel strongly either way, but that's kind of play around with it. But it is going to be recursion as the, like when you when you see a tree problem, most of the time it's going to be recursion. So okay, yeah. So let's see. Okay. So what I'm thinking right now is whether I should use this function as well. Generally, I'm not very good about it, but I think this one maybe you can do it. But usually I just use a helper function because it's just easier. So let's do that instead. So if no, true. So here we want to return whether this subtree contains all zeros. I think that's the criteria as well. Yeah, I mean, another way of saying this is if this all zeros, if it doesn't contain a 1. So yeah, just looking at the examples. And here the base case is true because then we can remove it, but it shouldn't matter either way. So no dot value is equal to 0, then we do stuff, because otherwise if no dot value is 1, then we're done for the subtree because you don't have to do a recursion because by definition, oh wait, that's not true. Okay, so I guess we have to do it either way. Okay. So we want to do something like prune.no.left, prune.no.right. So if this is true, then we remove none. This is roughly right, but we have to keep track of this. Yeah. Naming things is hard, but yeah, let's just default to no dot value is equal to 0. Here, then else false. So something like this. And then now all we have to do is we return the root. What I'm checking right now is just to see whether what happens if it's all zeros, like even the root. But I guess we could just test that. Maybe just something like this. Let's give it some spin. And also just put in some normal test cases that they give you. Just a little bit sprinkle. Little bit of a tree. Let's give it a spin. I mean, this looks okay, so let's give it a submit. Cool. Yeah, accepted. So that's not that bad. Yeah, so as you can see, this is a, and I guess I did a pre-order though. It's more post-order, but whatever. It is a recursive problem. For each node, we do, constant amount of work. So this is going to be linear time in total because the n nodes. And yeah, in terms of space, because we want to consider the stack space, it is going to be linear space, or h space, where h is the height of the tree. Yeah, overall a pretty straightforward problem. And definitely, if you are struggling with this problem, I definitely recommend doing a lot more tree problems and recursive problems, because they do come up on interviews all the time, and of course competitive all the time. So yeah, that's all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button. Join me on Discord. Y'all have a great weekend. Yeah, stay good, stay cool, and to good mental health. Bye bye.